Hi, grade 9s. So in this tutorial, we're going to review ionic and molecular compounds, which is what we've done this entire week. So you've already done all this material, that's why it's called review. We just figured we would wrap up the week by comparing the two. And so the idea is that you do this handout on your own first using your notes and the other tutorials, and that you're just double checking your answers using this video tutorial. And in doing it as a video, we can do some explanation as well. So the first thing you had to do was use these two examples and show using Lewis dot diagrams how each of these different types of compounds is made. And so I'm just going to go over to my document camera and we'll draw it together. So the very first one that you had to draw, need to make sure we're focused here, was MgCl2. And there we go. So MgCl2. So in the formula, we know how many atoms that we're going to need of each. And so we need 1 magnesium and we need 2 chlorines based on the subscripts that are there. So we're going to draw Lewis dot diagrams for both of those. Magnesium has 2 valence electrons and chlorine has 7. If you're not sure how to get those numbers, then you should look back at previous tutorials because we've done this quite a bit already. Okay, so each of the Cls, each of the chlorines has 7, magnesium has 2. Now, metals, magnesium is an example. They're always going to be the ones to lose electrons to become positively charged ions, which are also called cations. So they will lose their electrons, and the non-metals are going to be the ones to gain the electrons, becoming negatively charged, and they're called anions. And so we can draw this by doing something like that. So one of the electrons goes to that chlorine, the other one goes to the other chlorine. And just to finish off, when we have ions now, we can draw the summary with square brackets. And we did this in the tutorial too. So we're going to draw chlorine with all of its 8 electrons now, and the charge that it got as a result. Magnesium lost, so we're not going to draw any electrons in there. It's not like it doesn't have any at all. It just lost them in its outer shell so that it has a new outer shell that's full. And then the second chlorine we'll draw the same way. Okay, and then the other example for molecular compound, that was CO2. And we know that in a molecular compound, the electrons are shared, so we're just going to draw this a little bit differently. We have oxygen sometimes to differentiate between electrons. We draw them with circles and X's, just so we know what electrons belong to who. So oxygens, they have 6, and carbon has 4, and so they're going to share electrons. They both want 8, and so let's say we do. There's one set that can be shared. There's another set that can be shared. Same thing over here. So what we end up with is actually 2 sets of double bonds. So we can draw it like this. And we'll do any unpaired electrons hanging out on the outside. So we can double check. We can count to make sure all the electrons are accounted for. Everyone wants 8. And so for oxygen, it has 1, 2, 3, 4. Each bond counts as 2, 5, 6, 7, 8. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. So it's good. And the other oxygen is the same. So it's good too. So that's how we draw them out to show what's going on. And I will just take a picture that I took earlier and stick it into this document to show you. Okay. So the next thing that we have to look at is something that we already talked about through that explanation. What's in these different kinds of compounds? Well, in an ionic compound, we have a metal and a nonmetal. In molecular, there's only nonmetals. There might be 2, there might be more though. Usually we had 2. So the types of bonds in an ionic compound, they're ionic bonds, and you have to describe what that means. So electrons are lost by the metal, and that means they become positive ions, and those are called cations. Those electrons are gained by the nonmetal, making a negative ion, which is an anion. they're called. So the attraction, how do we get the actual bond? The attraction created between the positive and negative ion, that's what makes what's called an ionic bond. In molecular compounds, they're called covalent bonds. Sometimes we call them molecular bonds. And the word co helps to figure out what's actually going on with the electrons because they're sharing. And so when you're a co-president or you're a co-pastor, you're sharing responsibilities. So covalent is sharing electrons. Electrons are shared by two or more nonmetals. Okay, we talked about physical properties. So typically, ionic compounds are solids, and we also mentioned that they form crystal structures, meaning a very regular pattern of positive and negative ions. They have a high melting point. They have high conductivity when they're dissolved in water and try and conduct electricity. And they have high solubility in water, very easily dissolved in water. Molecular compounds can be solids, liquids, or gas. You can look at a periodic table. Sometimes they tell you, and you'll see that there's all three of them throughout nonmetals. Melting point is quite low. Conductivity in solution is low, and solubility is also low. So you can see how they're quite different from ionic compounds. So how do you find the formula if you're given a name for an ionic compound? First thing to do is find the symbol for the metal and write it in ionic notation. For example, if you have sodium, for example, you find the symbol is Na, and the way we write it in ionic notation is just by doing the superscript of the charge. Now here, it's a perfect opportunity to show you how to do superscript. Some of you are asking about this. This is how you can do it, and you must do it for the test and for assignments, because the way that these things are written, superscript versus subscripts in a formula, is really important. And if it's not done that way, then it's actually wrong. And so you have to make sure that it's either superscript or subscript if it's supposed to be that way. And if you're not sure how to do it, then I'll be doing that a couple of times. So we'll go back to regular. Okay, so the first thing that you would do then, oh, we're still in subscript. I'm just going to delete this actually. So find the symbol for the metal and write it in ion notation, and then find the symbol, same thing for the nonmetal, and write that in ion notation as well, so you just know what the charges are. Then you're going to do the crisscross rule. And if you're not sure what I mean by the crisscross rule, you should go back and check your notes. Basically, we're taking the numbers from the charges and we're making them into subscripts for the formula, and we're crossing them to the other element. So for example, if I gave you potassium iodide as an example, potassium is K plus, iodine is I minus. So when we do the crisscross rule, you just actually end up with Ki, because they're just ones and you don't have to write the ones. Okay, steps to find, actually let's do the molecular compounds. So how do you find the formula if you're given the name for a molecular compound? Well, you find the symbol for the nonmetals for both of them and use prefixes, so mono, di, tri, etc., to determine how many of each atom there are. And then you're going to use subscripts to show that in the formula. So for example, if you had an example like carbon dioxide, you would write the symbols first. Oxide would be for oxygen, and then carbon, of course. And now we look at the prefixes. Use the prefixes to determine. So there's nothing in front of carbon, so there's just one. And there's di in front of oxygen, so that means there must be two. So write in two. If I were just to leave it like this is wrong. This is not how you write a formula. So I have to make it a subscript, like I said earlier. Okay, steps to find then the name. So you're going to name the metal in an ionic compound, and then you're going to change the name of the nonmetal to whatever it is in ide. For example, in the example that we had here, again, we'll make sure that all of the subscripts are in here. So MgCl2 ends up being magnesium, that's the metal, and then change the nonmetal to an ide ending. For a molecular compound, you can name the nonmetals. Then use prefixes to indicate how many of each atom there are. So for another example, let's say we had N2O5. Make these both subscripts. It's a little bit tedious. It's understandable. If we were to write it out, it doesn't take as much time, of course, but we want to make sure that we're accurate. So the two nonmetals are nitrogen and oxygen. We still need the "ide" ending, and all we have to then do is add prefixes. So there's 2 nitrogen, so dinitrogen, and there's 5 oxygen. So pent for 5, ox, and then change the ending to I, dinitrogen pentoxide. Okay, so now we have a whole bunch of questions. Remember, you have a test on Tuesday. These questions are, none of them should take too long if you know what you're doing, but the point of giving you so many is to give you lots of opportunity to practice, because that's really key. And so whatever you have time for, you should attempt. And let us know if you have questions. All the best.